Alright, 27 here. There's a couple of approaches you can do here with this one. One approach is, since the entire bottom chord here is x, we could go and call this piece of the right triangle 1/2 x, but some of y'all typically mess up on the arithmetic piece here when you do the Pythagorean theorem, because you have to do 1/2 x squared. That'd be 1/2 x times 1/2 x, or 1/4 x squared after you simplify it. And then some of y'all mess that up from there on. So what I would do is actually call this a y, and then whatever we get for just y, we're going to go and take that and double it. We'll multiply by 2. So anyways, let's write this here as y squared plus 1 squared equals 3 squared. That's going to get us, y plus 1 equals 9. That's going to be y squared equals 8. Then we can square root that, and we'll get square root of 8. Right. And square root of 8 can simplify a little bit here. That'll be 2 square root of 2 for y. Okay, and then from there, since we said, okay, if y is half of that, we need to double it. We'll go off to the side here and say x will be 2, and then times whatever we got for y, which was 2 root 2. And our multiplication rules say that we only multiply the outside number by the 2 right there. So that'll be your answer there on that one after you double it. So in my opinion, that's the best way to approach it. 28, they give us a full circle, and they give us a couple of these arcs here. You have 92 right there, 126, and then you have this leftover arc. So the best thing to do here on this one is go and add up the 2 arcs that were given. So let's see here, 92 plus 126 is 218. And then take your 218, you're going to now do 360 minus 218, because all of the arcs need to add up to 360. And then that'll be 142. And then we'll write that in. And then what we're going to do here is use our formula chart from our test here, and we're going to use this one here in the middle. When you have a tangent line and then a chord right here, so the angle formed by the tangent line and the chord, it will be 1/2 of the arc that you're dealing with here. So let's see what that might look like here. So in that case, we got a couple of them here. We're going to go and divide the 142 by 2. Excuse me. And that'll get us 71 degrees. And then the 126 is just a traditional inscribed angle, so we just need to go do 126 divided by 2, and that'll get us 63 degrees right there. And then yeah, that should be it there on that. If you wanted to go get this last angle here, I guess you could go do 92 divided by 2, and that would get you 46. And then one interesting thing here is, since these 3 angles right here make a straight line together, they should all add up to 180 degrees, which they do. So that'll be it there on that one. Okay, 29 is kind of a special one here with angles inside of quadrilaterals that are inscribed in a circle. They need to add up to 180 degrees. And that's only specifically to quadrilaterals inside of circles here. So those two, 180 degrees. So just go 180 minus the 97 right there. I think, what is that, like 83 degrees. And that'll be it. Some people might be tempted to try and say, oh, maybe these two add to 180 or these two add to 180, but it's the ones that are cross from each other on these here. You could do the same thing here with this 105. If you wanted, you didn't need to do that on this problem, but that angle up there should be 75 degrees. And then everything should add up to 360 at the end. Okay, 30 right here. Let's see. So we got a couple of inscribed angles here. You got 60 degrees right there. If we double 60, we should be able to get x. X would be 120 degrees. And that's from just 2 times 60. For arc y, we would take the 32 and double that. I think, what is that, 64 degrees. And then I guess for z, you would double the 88. 88 times 2. I'm typing it in wrong. It's like 100 and something. 176 degrees. There you go. And then like we've done before, you can go and add up all of the arcs and make sure they add the 360 to check. So that should be it there on that. Oh, it looks like I had 31 worked out here. With 31, I see right here, I see a diameter line. And whenever you have a diameter line, we know that the diameter line splits it in half. So you'll have 180 degrees down there. This entire arc should also be 180 degrees. So what I'm going to do to find x is actually figure out this other piece of the arc right here, because then I can go and divide it by 2 since it's an inscribed angle. So we'll go and do 180 minus a 92 right there. It should get us 88. And then we're going to do 88 since that's that arc right there. Then we're going to half that and get 44 degrees for x since it's an inscribed angle. And that'll be it there.